let's look at Pascal triangle. With this code, I have generated a Pascal triangle of size 10. And you can see that each number in this triangle, like for example, this 2 is a sum of 1 and 1 from the previous row. If you take this 20, 20 is a sum of 10 and 10. This 15 is a sum of 5 and 10. 6 is a sum of 5 and 1. And this 6 is a sum of 5 and 1 and so forth. So if you take 126, it's going to be the sum of 70 and 56. So this is what a Pascal triangle is. And I've tried to format it here so that you can see it clearly. But generally in ZCubes, you can just say Pascal triangle and a number. And so Pascal triangle 10 will give you a Pascal triangle of size 10. And if you just simply changed it to, let's say, 32, you will get a much larger Pascal triangle with the appropriate size. Now, interesting thing is that there is something called Sierpinski triangle, which is some shape like this. And you can see that it has got this repetitive pattern of triangles. So the big triangle contains, these 3 triangles, 1, 2, and 3. And each of those contain in turn subtriangles. So this is 1, 2, and 3, and 4. So basically, each triangle is a collection of 4 triangles, 3 of them pointing upwards and 1 pointing downwards. So and if you take this triangle inside of it, you see another 1, 2, 3, and 4. And if you take this little triangle on the left side, it has got 1, 2, 3, and 4. And each of those triangles again have this repeated pattern. Now, Pascal triangle, Sierpinski triangle are related. And to see that, what I'm going to do is the Pascal triangle, I'm going to do a little bit of interesting coding here. So the slight change to the code, I'm going to be generating a pattern in which what I'm doing is I'm doing the mod of each of these elements by 2, and hence I get a bit pattern 0 or 1 because I'm taking the mod of each element in the Pascal triangle, and so it is going to give me either 0 or 1. And if you look at the pattern, there's something very interesting here. So let me generate this for 32 items so I can get the right size here to show you. So you can see that the last line, the 32nd line, is all ones. So if you drew a line, let me make it bigger here. Oh, let me do it differently. So I'm going to do this. So I'll draw certain lines on this here. So that is one side of the triangle, second side of the triangle, third side of the triangle. And then you see that there is a whole line of ones here, whole line of ones here, whole line of ones here. Likewise, whole line of ones here. So you're starting to see the Sierpinski triangle emerge from the Pascal triangle through that operation that I did. And in fact, if you go into this triangle, you see further, it's over here. And this is going to be, and again, so it keeps going smaller and smaller. Now, you could have easily created this for, let's say, 64 instead of this. And so you'll have a much bigger triangle. You can see that, you can see the patterns of the ones and so forth here. See, there is one line here. And so forth. So you can see that these two patterns are kind of related to each other. So that is a fun fact about Pascal triangle. We'll have more fun facts about Pascal triangles in other videos. Thank you.